In this situation, we are being asked what would result in A over C. What this question is asking is, if we apply the SOH CAH TOA formulas, which of those formulas would have A over C on the right side of the equals? There are 6 possible answers to this question, shown here. Sine of A, cos of A, tan of A, sine of B, cos of B, and tan of B. We don't include sine of C, cos of C, or tan of C because C in this case is the 90-degree angle, and with the SOH CAH TOA formulas we don't do the sine, the cos, or the tan of the 90-degree angle. But which of these, if it was on the left of the equal sign, would give A over C on the right side of the equal sign? If we look at the diagram, we can see that A and C are the upright and the base of the triangle, and neither of them is the hypotenuse. So we're not going to be using a formula that involves the hypotenuse, which means we're not using the SOH or the CAH formulas. The answer is not sine of A or cos of A. The answer is not sine of B or cos of B. It has to be either tan of A or tan of B. If we try tan of B and build the TOA formula with it, we get tan B is equal to opposite over adjacent, which would be C over A. And that's not what was given in our question. We have A over C. We have to try tan of A. Tan of A would be equal to opposite over adjacent, which would be A over C. So that means that the only one of these 6 that would give us A over C on the other side of the equals is tan of A. Therefore, tan of A equals A over C is the filled-in TOA formula and the only one that would give us this result. In this example, we are being asked, in right triangle PQR, what would result in Q over P? We have 6 possible answers: sine R, cos R, tan R, sine Q, cos Q, tan Q. We are not considering sine of P, cos of P, or tan of P because P is the right angle. Of these 6, if we were to plug them into the SOH CAH TOA formulas, which one would give Q over P on the right side of the equals? Well, one clue we have is that P is involved, and in this diagram the P is the hypotenuse. So we know this is not going to be the TOA formula. It is not tan of R or tan of Q. When we investigate the other possibilities, though, what we discover is that there are 2 possible right answers: cos of R and sine of Q. If we do cos of R, that's equal to adjacent over hypotenuse, and that would give us Q over P. But if we do sine of Q, that's equal to opposite over hypotenuse, and that would also give us Q over P. In this case, there are 2 right answers to this question. Cos of R is equal to Q over P, and sine of Q is also equal to Q over P.